I'm going to describe the way that I calculated the standard deviations for the differences, where you're combining the standard deviation for the initial pre-state and the standard deviation for the final state to work out a standard deviation for the difference. This within software is what you would do in the t-test. There are different ways of doing it. The particular formula I've chosen is this one. So the standard deviation for the combined data is the square root of size of the first sample minus 1 multiplied by that standard deviation squared of the first one, so the variance of the first sample, plus the size of the second sample minus 1 times the variance of the second sample divided by the total of the sample sizes for group 1 and group 2 minus 2. This is hopefully a reasonable, unbiased estimator of the standard deviation that combines the two rather than just using a simple average. Now, because you want to calculate those standard deviations and I'm going to actually use that same calculation process for multiple papers, it makes more sense to put them into a spreadsheet and to use Excel to do the calculations. So what I have here is the standard deviation before, standard deviation after. This is the standard deviation before squared, the standard deviation after squared. This is n minus 1, and n1 plus n2 minus 2. Now these will be the same as one another because it's the sample pre and the sample post is the same. Now, if we were going to do this properly, we should do paired differences. But we can't do paired differences because we haven't got access to the raw data, so we're going to have to use this. Now, this is going to give a standard deviation which is actually going to be bigger and worse than the actual standard deviation if I did a paired test, but it's the best that we can get. So the next thing is to add together the squares multiplied by each of the sample sizes, then to do the division, and finally to create the square root. So in this case, to know that I've got reasonable answers, I'm looking for something which is between 1.5 and probably 2.5. And if you look here, all of these standard deviations that I've calculated are in the ballpark area. The one paper where it's different is Takakura. That's particularly a difficult paper because the data had to be extracted using graphical methods. All of the other ones are very similar to one another.